we will look into the sine series program. The main purpose of this program is to compute sine of x using Taylor series approximation method given by sine of x equals x by 1 factorial minus x cube by 3 factorial plus x to the power of 5 by 5 factorial minus x to the power of 7 by 7 factorial plus etc. The computed sine of x value will be compared with the built-in library function and both the results will be printed as the output. This program also demonstrates the usage of do-while looping constructs. The input what we are giving into the program is degree. The output what we are getting is the value computed from sine of degree. Now, let us look into the logic of this program. The logic of the sine series program is as follows. The Taylor series approximation method, the standard formula for sine of x is given by x by 1 factorial minus x cube by 3 factorial plus x to the power of 5 by 5 factorial minus x to the power of 7 by 7 factorial plus so on. Here we need to carefully observe that each and every time takes an alternating plus and minus signs, and this entire term which constitutes of a numerator part and a denominator part is togetherly called as a term. Here in the numerator we can observe that there is a rise in power of degree 2, and in the denominator the corresponding factorial will be there. That is, for x to the power of 1 the denominator is always 1 factorial, for the x to the power of 3 the denominator is always 3 factorial and so on. Now, as we discussed earlier, this program deals with do-while looping constructs. Let's look into the syntax of the same. Here, the do-while is a looping construct which executes a set of statements inside the do block at least once before checking for its condition in the while part. In our program, we have the code to look into the same. Here, as I discussed here, this part is known as the do part, and while the condition is checked at the last. How exactly does it works? The first line is term equals num by denominator. As I told you, each and every term is a combination of numerator by denominator. Next, numerator equals minus numerator into x into x. This minus is due to the alternating sign of plus and minus in our each and every terms with an x and x. Two x's multiplying results in x square, which rises to the power in every 2 times. In the denominator part, we have deno equals deno star I plus 1. This is because we need to increment each and every denominator by the value 2 and correspondingly calculates its factorial. At the last, we have I is equal to I plus 2. While, what's the last condition here? It checks while fabs of term is greater than 0.0001, which means to say that it checks for a maximum of 4-digit decimal accuracy. This is the logic of the sine series program. Now, let us look into the program to calculate sine value of a given angle. The very first line here is hash include stdio.h, which is used for preprocessor directive along with standard input output header file. And we also make use of another 2 important header files, namely the conio.h, which stands for console input output header file, along with math.h, which is used for mathematical operations. After this, we have a very important preprocessor directive which is used as symbolic constant. Here, hash define once again a preprocessor directive along with PI 3.142, which defines PI as a symbolic constant with the value 3.142, which remains the same throughout our programming. Next, we have the main function from where our program execution starts. Inside the main function, we have the declaration part. Here, we will declare the variables I and degree as integer data type, followed by other variables such as x, sum, which is equal to 0, term, numerator and denominator, which are declared as floating data types. Next, we have clear screen, which is used to clear the output screen. Now, we need to enter the value of a degree, hence we have written that inside our printf function. Next, scanf accepts input from the keyboard, hence we have this %d, since the value of degree what we give is in integer data type. Next, since we give the value of our degree, we need to convert the given degree to radians to actually calculate the sine of angle. Hence, to convert from degree to radians, we have a formula which is written as x equals degree into pi by 180, which converts the given degree into radians. Next, numerator is equal to x, denominator equal to 1. This is used for our very first term in our sine series, which stands for x by 1 factorial. Since the first term has already been defined, we will start from the second term, hence I is equal to 2. Next comes our do while looping constructs. That is, here term equals numerator by denominator, numerator equals minus num into x, denominator equals denominator star I plus 1, sum equals sum plus term. I is equal to I plus 2, while fabs of term is greater than or equal to 0.0001. This entire do while constructs has been clearly explained in the logic of our program. Next, we need to print the sine value which has been calculated by our program. The sine of %d is %.3f, that is degree and sum. So finally, the sine function has calculated value, that is sine of x. Since in our question it has been asked to compare the calculated value to that of sine of x built-in function value, we are printing both the results. Finally, we terminate our program using getch. The program is ready for compiling and execution. As we know, the steps for compiling is Alt F9. Since there are no warnings or errors, we can see 0 warnings, 0 errors. Next, the step for execution or running of the program is Control F9. Here, it asks us to enter the value of a degree. Now, let us enter the sine value what we want to compute as, say, 30. The value of sine 30 is 0.5. Since in the first line the sine of 30 is 0.5, that is the value which has been computed by our program, and the second line is what that has been computed from the library function. As we can see that both the answers are one and the same. Now let us take one more run for the sine series. Now let us give the degree as 45. Here also we can observe that the value of sine 45 is 0.707, which is true in both the cases. Finally, let us run it for sine 90. As we know, the value of sine 90 should be 1. Let us check whether we get the same value. Here we can clearly observe that our calculated value and the library function value both are having the sine 90 value as 1. This completes the execution of sine series using Taylor's approximation method.